So first of all, thank you, and sorry, I'm not Bartek. There's no Dino on my presentation. There's some Node on my presentation, but that's it. I hope you don't mind, or at least you won't mind tomorrow, or on the after party. So yeah, we're going to talk about the cross-browser performance compatibility. Would it be possible to get this cursor out of the screen, maybe, by chance? Yeah, anyway. OK, thank you, cool. Maybe I see it as well. Let's hope. OK, so cross-browser performance compatibility. If you put it into Google, there's nothing there. I coined this term. Hopefully, I'll make something out of it. But basically, what it means is that if you are working as a front-end developer or as a developer in general, the point is that Chrome is not enough. Like, it's not a bad thing. If you're working with Chrome, don't feel called out. I'll be calling out other people later, don't worry. It's going to get only worse. But basically, it's not enough. And we have to think about it. And we have to start talking about why this is not enough. So first of all, something about me. Some of you may know me. I'm head of engineering at Vasco, but only till end of this weekend, because then I'm going to be head of engineering at Alino. If you want to know why and all that story, you can catch me later. I'm a very chatty person, sorry for that. From like other things, I'm a current contributor at meet.js. If you heard about this framework, then I'm surprised. But hey, it's almost 10 years old. So if you want to learn something about it, like feel free to chat about. But basically, if you liked the talk in the morning about server-side send events, this is like real-time framework from ground up. So something you might be interested in. Then I'm also an author of uniforms. This is basically a React library. And why I think it's important here is because those two projects are all projects, libraries, frameworks. So we don't have our target audience. It's not a project that you just ship to your, I don't know, project, you sell it. It's a library, open source projects. And basically, we have users from every different runtime you can imagine. And finally, if you want to hear anything else, if you don't feel fed up with me already, then there's a website. You can find everything there. So cross-browser compatibility. I guess everyone knows the definition, but here's some Wikipedia. I won't read it. But basically, the point is that we are trying to build the applications in a way that if the application is opened in a browser or some environment, or maybe on a device that is not really capable of handling everything we wanted or everything we would like it to happen, the application or the website is actually ready and actually prepared to degrade a little bit, but still be usable. So for example, today, it's not really that much of a deal to actually make it happen. Like most websites are working in most browsers. But if you just swap back to like 5 or 10 years ago, who remembers all those browsers that just said, OK, we only work on Chrome, or fuck you, Firefox, or Internet Explorer is the only way of living. So that's basically what we had there. And if you are looking for things that are actually supporting this kind of approach, we see jQuery. OK, I hope nobody of you is forced to use jQuery today. But 10 years ago, jQuery was the way of working with things. It was basically the only option, instead of like doing the same as jQuery in your project, to actually have everything working across the browsers, right? Now, you no longer have this problem, because we have more or less better standards. More companies are working with the standards. The browsers are more up to date. The browsers are very pushy about updates. I know that some of you have this like red icon in your Chrome just dingling, hey, you have to restart the browser, I know, and you are very precious about like those hundreds of tabs you have open. I feel that. But like, it's easier nowadays, like much easier. But then if you look on the other side, so let's say on the right hand, there will be libraries, and on the left hand, well, there will be some infrastructure. So we have core.js. A very funny story. If you know the author and you know what he did, then you know what he did. If you don't, try to look it up. It's a really interesting story. But basically, we already had the situation when a very important maintainer of a very important project that you definitely have on your computers thousands of times in all of your node modules went to a jail for a year. And it's a problem, because then the development stopped for a year. So a very interesting thing. But basically, this is an option for us to have our projects work in every environment automatically. You are using your code base, using some functions. I don't know, you go to a conference like that, and you see that, hey, there's a new function, string prototype.replace all. Hey, I want to use it. You use that, and then your customers are calling, hey, it does not work on my, I don't know, Edge 14 or Firefox 97 or whatever, right? So you can just throw that Of course, it requires some setup, maybe some browsers list configuration, and this and that. But basically, in the end, your code is not touched, and it still works. It polyfills the problems that you have to polyfill. So basically, fulfill the missing functionalities in your browser, or in more general, a runtime of yours. Then again, on the right-hand side, we have something called _JS. You may know it's younger brother, or a child, or maybe even like more, I don't know, unloved child, Lodash.js. Basically, Lodash became de facto a standard today, and on the other hand, we have to use it less and less because we have more and more libraries in the standard, as for example, we'll just replace all on the string that was added in ES 2022, I think. But basically, this was, again, something that was the standard for us. Before ES5 happened, there was no object keys, no RI prototype map, no, I don't know, function call. Like, even those things were sometimes problematic because, for example, they had some quirks that in Firefox 4, calling function prototype apply, I think accepted up to 4 parameters. And then you have to deal with it yourself. So like very different quirks, and those libraries were there to help us and actually help us to make the web happen as we have it today. And then again, to the left-hand side, slightly, we have a very modern approach to those things, which basically combines all of those what we have, and this is bubble preset env. You may know it without the @ sign at the beginning and a dash instead of a slash, because they just moved all of their NPM packages into an organization on NPM, but basically this is like even more automated way of working with core.js, where in core.js you had to implement and import the polyfills you knew you needed into a way where you just say, I want it to work on Chrome 108 and newer, and that's all I care about. And this tool takes care of it, because it actually knows which browsers require which polyfills, right? A very decent way of working. Okay, but then I come to the stage and I say I want to put performance in the middle of this term, and you put it into Google, and there is nothing about that. And that's a problem, because I just invented this term. So let's think what the problem is. The problem is that different browsers have different performance capabilities, or different performance characteristic, right? So you write a program, and it runs in all browsers, it just works. That's the cross-browser compatibility. It works in all of the browsers. But now the problem is that it works at different speeds between the browsers, okay? So let's have a case study. A very simple function. This function is going to concat all of the arguments that we are going to give it, but basically to a string path. If you ever worked with Lodash get or Lodash set, you most likely know what this function is going to do. Okay? So if we give it a single string, it just returns this string. Nothing fancy. If we're going to give it an array of strings, it's going to flatten those and then combine them with a dot. Simple as that. Then, of course, we want to accept numbers. So if I put a 0 in there, it also works. Then if there's something falsy, so like undefined, maybe an empty string, a null, we don't want them, we just skip those. And then if you combine all of those into one example, it looks like that. I guess you know the drill, you know how it's supposed to work like. Basically, this is not a function that I just imagined. It's a core function of uniforms. It's basically a function that is executed hundreds of times when you're rendering a big form on your website. Hundreds, literally hundreds or even thousands for really, really big forms. So it's an important helper that is executed a lot of times, and it would be nice to make it faster, because the faster it is, the faster the form we are working in is. So let's have some naive implementation. A very naive one would be to get all of the parts, and we are going to somehow combine them into a single array and join with a dot. Simple as that, okay? So we take the part. The implementation is not really that important, but let's read through it a little bit. So we just take the part. It's either truthy or 0, because 0 is falsy. Remember about it. And then we just concat into a single array. Okay, we have to split on dot if there's a dot. If none, then just leave it. And it's simple as that. I know some of you already see that there's a performance problem because we are using concat, and we are getting more and more arrays in between. I know, but stick with me for just a second. And now let's benchmark it first. Right? Before we jump into a better and more optimized implementation, let's benchmark this first. Okay, so we prepare some benchmark for us. We have our samples from the first slide. We run it in 50 rounds because we want to account for like different timings, maybe just-in-time compilation kicking in, all those things. And we do it 100,000 times each round. Okay, simple as that. It will generate a lot of console time logs in your console. There's a tool that we built at Vasco to cooperate with that. You basically just Control-A, Control-C, Control-V into this tool, and you have like a summary with averages, standard deviations, and all of it. So let's do that. And let's look at different browsers. First, Chrome 117. I think that's the latest one. At least that was the latest one on Sunday. And the average time is 38 milliseconds. Is it a lot? Is it not a lot? It's hard to tell. It's a number. Okay, this number is not really important. What is going to be important is that, first of all, this number is significantly lower than the maximum. If you want to know why, you go to V8 blog, or maybe talk to Ola, again, if she's here, like the one that gave the first talk of the day, basically why the compilers and the interpreters are working better if you run the same thing over and over again. But let's stick to the benchmark. Then we run the same code on Safari 16.6. I know that there's Safari 17 already. Sorry, these slides are slightly older than this Tuesday. And it's significantly slower. And that's life. That's basically what the other browsers are optimizing for, but then we run it in Firefox, and it's even worse. Okay, cool, got it. That's a benchmark, right? It's not about making fun on everyone, it's just about seeing how our code performs in different environments. Okay, so the first takeaway is that the difference between those is massive. Like, it's threefold difference between Firefox and Chrome, right? And these are all latest versions on the same machine, on the same day. Nothing running in background, no like 4K Twitch stream in other tab, no. Like free CPU and just like running them to see how it works. Then it's really significant to see that the just-in-time compilation actually helps a lot. Of course, it depends between the runtimes, because V8 has a really like Sparkplug optimization phase, then TurboFun, GIT compilation. Firefox has its own Iron Monkey, and Safari has, I don't remember what's in JavaScript core, but basically, the difference between maximum and average is significant, right? We can actually see that, we can actually feel that. But then, of course, Firefox is not really that well anymore, right? So let's make it better. Let's think about some better implementation. The exact details are not that important, but let's go through them again. So we are going to have a standard for loop. It's basically a fixed point algorithm. We're going to unroll it part by part, pushing to the same array, handling arrays, strings, numbers, whatnot. It's not really important that you understand this implementation, but the point is that it's more complex. It took us some time to develop it. It took us some time to measure that it actually works. It took us some time to test it as well. Okay? But you can actually see there's a public pull request. This is not something I just imagined for this conversation and for this presentation, but this is basically a true pull request that I made, I think, a year ago or something, with this exact implementation. So what we have to do now, to be fair for everyone, we have to run benchmarks. So let's do that. So first of all, we try on Chrome. It's 25. If you don't remember the numbers, the most important thing is that it's faster, 33% faster. That's good. Then we go to Safari, 44, so that's 29% faster. Awesome. Then we go to Firefox, 101, still terrible, but still 4% faster. That's nice, right? Review is there. All of the unit tests are passing. All of the end-to-end tests are passing. So we released it. Everyone hits it. It hits the customers. And then there's a Slack message from somebody. And there's a GitHub issue from the other person. And they say that it's worse, like significantly worse on Firefox. But I had my 4% on the previous slide. What's happening, right? Like, what is happening? It can't be true. So we go back to the benchmark that we created on the first step, and we add, like, we have those cases from the first slide. So let's add one more, this very complex one, right? And it turns out that it's actually a very true and more, let's say, accurate to our users' usage of this function. So we add this one here, real-time, real-life scenario. OK, let's run the benchmark again. So we have to now test the first implementation and the second one, right? Because we changed the benchmark, so we have to test both implementations. So what we do, let's try the first version from Chrome 117. It's 80 milliseconds. If you don't remember the numbers, again, it's much bigger, right? So version 2, much better. 80 versus 50, great. 37% faster in Chrome. That's awesome. Now, let's do the same with Safari, 101, 83, 17% faster. It was 30-something, so let's say it looks like our implementation for this very benchmark profited more on Chrome and profited less on Safari. The actual truth and the ground truth is that actually it was faster in Safari in the first place, the harder case. But let's keep that here. And then we go for Firefox, 158 and 180. Shit. So it's 14% slower in Firefox, and that's a bummer because we just implemented something. It's much faster in Chrome, it's much faster in Safari, and it just sucks in Firefox. So what do we do now? Like, we have to do something. Like, the customers are calling. We have some GitHub issues created from those people. So we have to think. So first of all, what we can do is we can just spend some more time on that. Spend 1 more week, maybe 2 more weeks, I don't know, 40 story points, whatever do you, and hopefully we will come up with a solution that is faster everywhere, or at least not that much slower everywhere, okay? So that's one option. Another option would be to just leave it. So then we don't have this benefit on Chrome, we don't have this benefit on Safari, but we still don't have this lose on Firefox. That's an approach. You can go that. But what I propose here, and what I propose today, is we have to calculate how much of an impact does it have, right? It's kind of hard how to calculate an impact if we have like 33%, 33, like 17, minus 14, whatever. So let's think about it. Let's take our analytics and see what we can do. OK, so now, if we are talking about web application, we are in a really good position because while there's a lot of processors, there's a lot of mobile devices, resolutions, and all of it, there's not that many of runtimes, right? If most of you, I guess, are using Chrome or Opera or Brave or Vivaldi or I think Arc, these are all Chromium browsers, so they have the same performance characteristics because they are all using V8 underneath. At the same time, if you're using Safari or Firefox or some maybe even different browser, there's a high chance that there's a different performance characteristics, so you have to take it into consideration. So let's look at our user statistics. So first of all, Chrome is on the top. This is the most common browser for our users. OK, cool. Then we have mobile Safari, then we have standard Safari, then we have Edge. And these are all Chromium or Safari-based browsers, so they all benefit from it. That's good. Then we have Firefox at 9% and everything other in 8%. So in total, there's a huge percentage of our customers who are going to benefit from this change. And there's some customers that we don't really know if they are going to benefit or not, right? Because some of them will benefit definitely. Some of them will be worse in this situation, definitely. And as for the rest, we would have to check it. We would have to check what kind of browsers are there. Maybe it also depends on the device itself, because sometimes V8, for example, optimizes for memory usage, but on phone it optimizes for power usage. So then we also have to take some time to think about, hey, maybe it's the same version of Chrome or the same version on Safari, but it's different on low power mode versus standard mode. Or maybe it's different on Wi-Fi and not on Wi-Fi, right? There's a lot of things going here, but we just simplify it down to the browser. So one more example, very quick one, trivial function. If, delete, and return. Nothing crazy. We can call it like that. Where it's coming from? It's coming from meet.js framework. But basically, we do 2 very nasty things here. V8 hates us, because V8 really hates messing with the structure of the objects. So we do something really crazy. We can change the implementation to a very straightforward one. We just do all of the cases. Of course, it wouldn't work if you would have like 20 ifs in there. It's just terrible. But basically, this implementation looks horribly repetitive. Like, hey, they told me to don't repeat myself and all of it. But this is awesome, because right now, V8 just loves us. It's just awesome for V8. So we can run the benchmark again. You can see the pull request link here. And when we run the benchmarks, we see that it's basically 50 to even 90% faster on Chrome. So it's 10 times as fast as the previous implementation. And between -10 and +10 performance on Safari. So it's sometimes slower, sometimes better. On Chrome, it's always better. But then we think, OK, where is this function executed? And this function is executed in the browsers, sometimes, but it's mostly executed on the server. And on the server, we are using Node.js, and Node.js is using V8, and this is the same runtime as our Chrome browser, or Chrome browser to be exact, right? So what's the decision? We just ship it, and it works, and it's awesome. So takeaways. First of all, remember to benchmark every single time. By reading the code, you have no chance of knowing if it's going to be slow or fast. There are some exceptions, some very edge cases, runtime-specific edge cases, but in general, you don't know how fast it's going to be. Secondly, you have to benchmark your real-life scenario cases, not just like some artificial numbers, artificial strings. No, just like throw what you have in there and see how it performs. Then it's important to benchmark in all of the runtimes that are important to you, right? Multiple browsers, multiple devices, multiple endpoints maybe. And of course, you have to count and account for your users, because it doesn't make sense to optimize it something 20 times on Firefox if your Firefox user base is 1 user a month, right? It makes no sense. And lastly, remember that there are more browsers. I know that most of you will have more browsers on your PC because sometimes a client is calling, hey, it's not working on Safari, or hey, I see too many scroll bars on Firefox. I get it. But just like remember, there are more browsers, more users, people with disabilities using different even operating systems. There's a lot of people around the world, and there are more browsers than your Chrome. And yeah, that's it for me. Thank you.
OK. Thank you. We're running short on time, so there's only going to be one small question, which is, what tool are you using for benchmarking?
Console time. Like really, console time is the best for you because console time, on the one hand, makes sure that it's actually within your runtime. Like date now is too imprecise. You can use performance now, it also works. But console time is best because then we also built this tool that I linked on the first benchmark slide. You can just really just copy paste all of your results in there, and you have a nice table with all of the summary in Markdown. So you can actually also copy paste it to GitHub. So that's my answer.
OK, thank you.
Thank you.